lesson, I want to talk about function notation. Functions are not something that you use right away, but if you take college algebra or calculus or any other advanced math class, you need to know about functions. So we do want to stress them a little bit here. Functions are represented by equation, and we usually, this would be an equation, y equals 2x minus 6 as an equation. This equation does happen to be a function. How do we know it's a function? Well, every unique value for x is going to generate just one unique value for y. If x is 1, y can only be 2 times 1 is 2 minus 6. Y can only be a minus 4. It can't have more than one value of y for any given value of x. That's the definition of a function. That makes this a function. So if we wanted to show that this equation is a function, we would use function notation to show that. And function notation starts off with, usually you use an f, but you use an f, sometimes a g is commonly used. X equals 2x minus 6. What does this say? What this is telling us is this f, we have a function. The function is a value, is a function of x. The value y depends on the x value. And we would say, when we see this, that translates into f of x, or the value of f at x. The value of f at x. So f of x equals 2x minus 6 shows us that this is a function. There can only be one value when x is a given number. And to find that value, you plug in the value for x. So let's do that. F of x equals 2x minus 6. For x equals 1, f of x is going to equal 2 times 1 minus 6, or a minus 4. So we could show that as f minus 1, or f, where's my eraser here? F equals a minus 4. F of 1 equals a minus 4. This tells us that when x is 1, the function equals a minus 4. When x is 1, this function equals a minus 4. F of x equals 2x minus 1. So if we put a 1 here, it means we substitute the 1 for our x, do the calculation, and we get 1 times 2 is 2, minus 4, or minus 6 is a minus 4. So f of 1 equals a minus 4. If f of x equals 2x minus 6, f of 1 equals a minus 4. That is function notation. And f is the name of the function. X is the domain of the function, and y, or f of x, is the range of the function. Now let's go back, and I want to present this in a little different way. Y equals 2x minus 6. We said, well, this is a function. We could write this as f of x equals 2x minus 6. What we're doing here is we're showing the dependency, the interdependency of these variables. Remember, we generate our ordered pairs by making a table, and we assume values for x and calculate values for y. We already did this for 1. X equals 1, y was a minus 4. If x equals 2, we'd have 2 times 2 is 4, minus 6 is a minus 2. If it's 3, we'd have 2 times 3 minus 6 is 0. If it's a minus 1, we'd have 2 times a minus 1 is a minus 2, minus 6 is a minus 8. So we've generated a set of ordered pairs using this equation. This is a function. A function means that x, values for x, generate separate values for y, unique values for y. Each value of x generates a unique value for y. So we can call this y a dependent variable. This is a dependent variable. It depends on the value that we assign x. Y is the dependent variable. It depends on the value that we give to x. So when we have a function, the x value is the independent variable. It's the variable which we choose to calculate our y, and y depends on, it's the dependent variable. It depends on the value that we assign x. So we have a function, f of x means this function is dependent on the value that we give x. X is our independent variable. This is our dependent variable. This is a function of x. This expression is a function of x. That's what that means. All right, let's stop it there.